superior, and we're going to continue working on that. But when you adopt a float, you're given a choice of which program you want to use. We also decided to have a sticker contest this year, and we got some amazing contributions, some amazing submissions for the stickers. And you can see some of them here, beautiful, beautiful stickers. The winning sticker was drawn by Kaylee at McDougall School in Chapel Hill, North Carolina. We liked it so much, we decided to use it for both programs, GO-BGC and SOCOM. And so we do now have some stickers available that we could ship out when you adopt a float. We'll send you some stickers too, just so you could use some of them with your students. And thanks to Dirk Slawinski, we're also starting to build some Lego floats. And these are the Apex, patterned after the Apex model. And I've been furiously building Lego floats. I think I have 50 of them built now. And we'll use these for outreach, as well as these beautiful education floats you could see in the right-hand picture. So these are were put together by Hans Janisch, who recently retired from MBARI. And these education floats are encased in a see-through housing so that you can see all the components of the float. And the floats are actually composed of real components, real sensors, just ones that are not working anymore. So we've gotten contributions, we've gotten donations from different sensor manufacturers, and we've been able to put these floats together. The only thing that's not real in the floats are the batteries, because putting real batteries in there didn't seem like a good idea for weight reasons, safety reasons, and because there's nothing in there that's going to work. So instead we have wooden dowels in there to simulate the batteries. We have these education floats available for use on the we'll have one on the East Coast and one on the West Coast. And Robert Key and myself and others have been taking these out to schools to let the students get an idea of what the floats really look like in terms of size, and what the sensors look like up on the top and what the float looks like on the inside. So these are a great contribution as well. We're also working on some lesson plans. Right now, the lesson plans that are on the website were mostly developed for the SOCOM project. So they're focused mostly on the Southern Ocean. We are starting to work on generating some specific lesson plans for GO-BGC for other ocean basins. And one of the people working with me on this is Emma Monson, a University of St. Thomas undergraduate student, who is also the first GO-BGC summer intern. And she's working with us virtually at MBARI. She's still back east at the University of St. Thomas, and she's starting to develop some of the templates that we'll be using for lesson plans. And she's also developing a social media outreach plan to try to help me get more floats adopted. So again, follow us on Twitter and keep an eye out for the social media campaign that Emma is in the process of developing right now. We also have a makerspace program, and this is run by Todd Martz at Scripps. And last winter quarter, as he called it, the winter quarantine quarter, of 2021, he had a graduate level class in marine chemistry, an instrumental lab, and he had students building all sorts of different sensors. And you can see some of the students here with the sensors that they built. Scripps will hopefully be opening up soon, and we'll be able to get the students into the makerspace itself to get some more hands-on work. And this is a great way to increase the workforce by getting students actually making some sensors and learning what goes into making the sensors and adapting them for use in different areas. And then finally, I want to talk a little bit about the MATE program. For those of you who are unfamiliar with the MATE program, the Marine Advanced Technology and Education, this is one of our main outreach partners for GO-BGC. MATE has been running an ROV competition, remotely operated vehicle competition, for many years now, and they're continuing even this year. The national competition will be in August in Tennessee, if you happen to be in that area. But you could also tune in and watch it virtually, because they've built a virtual workspace, a virtual competition space, so you could participate and enjoy the students who are building remotely operated vehicles and competing with various tasks. This year, as a part of the MATE competition, they've set up a separate challenge specific for floats. And so what MATE will be doing for their outreach is integrating float-related science and technology into the more traditional MATE ROV competition scenario and tasks. So this year it's a satellite challenge. In 2022, we'll start to add more challenges that are inspired by floats and sensor technology into the ROV competition and satellite challenges as well. So this year's challenge, which is now active, so if you know of any students that are interested in participating, you could still apply, is to build a device with active buoyancy, no thrusters or propellers, that could descend to depth and then ascend back to the surface, i.e. do a vertical profile. And the challenge, the winner, will be the person who completes the most vertical profiles in 10 minutes. So this is obvious technology that we're all familiar with now. This is a profiling float. It's inspired by the real world. And because of the pandemic, we're going to do it the real world way. Teams that are going to be involved in the challenge will ship their floats to the University of Washington, where engineers will complete a system check. And if the system checks out and everything's safe, they will launch the float into their test tank and then watch it profile. So the float has to arrive with a good battery voltage, with vacuum pressure, as well as full information to the University of Washington engineers on how to run a systems check, put the float to sleep, and how to activate the float to start its profile run. And then the specifications of the test tank itself, it's 4 meters deep. The float cannot be any taller than 1 meter, and it has to be less than 18 centimeters in width or diameter. It has to have an antenna, which will be non-operational. It doesn't have to work. Has to be held above the water line, at least 10 centimeters. And we're given 12 volts and a 5 amp maximum for the battery. And you have to be able to have a vacuum of 40 pounds per square inch. There is a video demonstration you have to provide just to show that the float actually works in addition to that. And then there's additional information with the challenge that talks about batteries and amperage and the buoyancy engine that can be used to power a float. And in the pictures, you could see the buoyancy engine that the Apex float uses. And as the final part of the operation checklist, you have to provide instructions on how to activate, deactivate, and talk to the float. And so if you do have questions, you could send them to me, or you could send them to MATE. And Jill Zande, Rick Rupan, and Matt Gardner are the ones who came up with and are running this particular floats challenge activity. And with that, that's all I have.